Welcome back to the second part of the lecture, how research infrastructures can take advantage of the interoperable VRE building blocks. In the first part of the lecture, we examined what research infrastructures are, what distributed research infrastructures like EPOS can provide to users, what is their governmental and technical organization. Let's now dig into some technical details and discover how technically a research infrastructure like EPOS is built and how it can be enhanced by using existing virtual research environment components. The EPOS architecture, described by means of an organizational diagram in the first part of the lecture, will be now described at the technical level. It is composed by Integrated Core Services Central Hub, ICSC, that is to say the place where integration occurs. Thematic Core Services, TCS, that is to say the European-wide hubs providing access to resources from one discipline only. And the Distributed Integrated Core Services, ICSD, that is to say external computational or visualizational services provided by third parties. It is not in the scope of this video to get into the details of the main ICS system by describing the modules represented by the colored boxes. However, it's worth to remark two main characteristics. The first characteristic is that Integrated Core Services Central Hub uses a microservice approach with the central queuing system and several components that performs atomic tasks and are connected to the queuing system. Examples of microservices are marked with red squares in the diagram: the queuing system, the connector to thematic core services, and the metadata catalog. The second peculiarity is interoperability. In order to connect integrated core services with resources provided by thematic communities and by distributed services, all the key stakeholders have to agree about protocols to be used to transfer information or datasets and metadata standards to enable appropriate transfer of information. This is where research infrastructures, composed by domain scientists and data scientists and engineers, actually provide an added value when it comes to real integration of multidisciplinary data. Now that we know the basics of research infrastructures like EPOS, let's try to understand how they can be enhanced by using building blocks from existing virtual research environments, in this case VRE4AC. For doing this, let's have a look at the main components or building blocks developed in the context of VRE4AC. VRE4AC has designed an architecture and began a prototype implementation of its building blocks. Building blocks are basically the components of VRE4AC reference architecture. Technically, each building block is a microservice implementing a major component of the reference architecture. The diagram in the picture shows the building blocks of the VRE4AC. In the framework of this lecture, we are not supposed to deal with the details of each building block, but just with the functionalities of those that have been integrated within the EPOS research infrastructure. So let's have a look at them with the black box approach. The first building block we consider is the AAAI service. AAAI stands for Authentication, Authorization, Accounting Infrastructure. That is to say, a system to manage user secure access to a system with authorization. The main characteristic of this service is that it integrates different authentication mechanisms into one single system, thus providing a user a single point of access to resources. In practice, it means that independently from his or her account credentials, user will type them in one single form. Integrating it into an existing research infrastructure like EPOS means avoiding the efforts of integrating many different authentication services into one research infrastructure, with all the related technical and security issues. EPOS tested the module and the results were encouraging, as it enabled EPOS users with existing credentials to log in to EPOS in an easy way, without jumping from a website to another. It indeed integrated several heterogeneous identity providers like Edugain, Google, but potentially what we aim at doing in the future, also other providers, both academic and generic, for instance, ORCID, GitHub, and Facebook. The diagram in the picture shows how EPOS has integrated the VRE4AC AAAI service building block. Without getting into the details of the diagram again, what is evident is that there is a real-time connection between the EPOS research infrastructure system, represented by green boxes on the left, and VRE4AC building blocks, represented by red boxes on the right. These components interoperate in real time, thus providing the functionality of logging in to the EPOS web interface by using the services provided externally by VRE4AC. All this complexity is hidden to the user, who just insert login and password in one simple login form. The second building block tested within the EPOS is the workflow service. Generally speaking, workflow management systems enable users to create, execute, and store business processes. Scientific workflow belong to this wider category of workflow management systems, but are specific for science. They allow users to compose and execute a series of computational and data manipulation steps. The sequence of this step is called a workflow. Also in this case, setting up a workflow system from scratch can be quite expensive in terms of effort dedicated to developing the system. The possibility of integrating such components into one existing system incredibly boosts the operational curve, that is to say, the time and the efforts spent to set up a system at its operational state. The diagram in the picture shows how EPOS has integrated a non-scientific workflow management system, Taverna, by means of the VRE4AC workflow system. Again, without getting into the details of the diagram, let's consider the EPOS research infrastructure components in green, the VRE virtual research environment components in red, and the workflow application running on a laptop in orange. When a user creates a workflow within his or her Taverna desktop instance, the components interoperate, and the user can manage the workflow from desktop application without bothering about the underlying complexity. To do this, a user simply has to install a VRE4AC plugin in Taverna. The installation is very simple and incredibly facilitates the creation, usage, and management of scientific workflows. The user just needs to add the plugin into Taverna by providing the plugin URL, as shown in the running demonstration. Once the plugin is installed, Taverna will connect to VRE4AC catalog and retrieve the list of available catalogs from EPOS. In this case, a list of catalogs available from the EPOS research infrastructure, which includes services providing access to earthquake data and historical earthquake maps. Access to such resources will enable users to construct scientific workflows that use datasets provided by one service, as for instance, input for another processing service, or simply retrieve data of interest for their scientific application. The two examples just provided lead us to discuss the added value of existing building blocks in any virtual research environment system, as in the case of VRE4AC. The conceptual components of VRE architecture, developed as building blocks in a microservice framework, are an added value to the scientific community, in particular for those research infrastructure whose goal is to harmonize resources as datasets and services in a multidisciplinary landscape. The first added value is that they enable the use of resources provided by external resource provider. External resources can be external data or data products provided by data centers at national or international level, as in the case of Orpheus IDA organization providing seismological datasets. Resources can also refer to the computational domain, as in the case of national HPC centers or other processing resources in the framework of the European Open Science Cloud. Use, reuse and integration of existing resources, even outside the scope of research infrastructure developments, is strongly encouraged by European Commission. So the interesting side effect of those building blocks is to cooperate to a sort of synergy building action currently going on at European level. The second added value is that providing technical solutions based on standards enable the specific communities to be interoperable with other initiatives. Again, it is quite relevant in the European Open Science Cloud scenario. The lecture is now over, and if any of the topics we discussed stimulated your interests, we suggest you to have a further look at the EPOS website for better understanding what research infrastructure is supposed to provide to end users. Visit the VRE4SC website to check what it can provide as virtual research environment and what are the existing resources you may use. Make a search on GitHub with the VRE4SC and the EPOS keywords, so to understand what developments are available and what can be reused. Also visit the ENVRI+ website, a European project that includes many environmental research infrastructures. See you next time.